Greetings students. In this lecture, we'll talk about the series expansions of functions. If f is defined in the interval containing a and its derivatives of all orders exist at x is equal to a, then Taylor series expansion of a function f of x at x is equal to a is f of x is equal to f of a plus x minus a f derivative a plus x minus a square plus f double derivative a over 2 factorial plus up to x minus a raised to power n f n power derivative of a over n factorial. Or if we write it in this summation form, we have f of x is equal to summation from 0 to infinity f raised to power n a or f n derivative power a x minus a raised to power n over n factorial. Now this is a generic formula of the Taylor series expansions of a function f of x, and that is only if the interval containing a and its derivatives exist at a. Now, how would you find it? You will put the value of a in the place of x to find f of a, and then of course x minus a is easy. You'll take the first derivative of f of x and then put the value of a, and then you'll take the second derivative of f of x and then put the value of a, and then so on up to you get your final answer. I hope you got the concept. Now moving on, we have if f is defined in the interval containing 0 and its derivatives of all orders exist at 0, then Maclaurin series expansions of a function f of x at x is equal to 0 is. Now in the previous case, we studied the Taylor series, while in this particular case, we are studying the Maclaurin series. Now Maclaurin series is a special type of Taylor series, so don't consider them different. Now, if we just consider the generic formula that we studied in the previous slide, that is, in the place of f of x, we put the value of x, that was a in that case and 0 in this case, and then we had x minus a, but here a is 0, so we write x, and then we take the first derivative of f of x and then put the value of a, that is 0 in this case, and then we have x minus a whole square, as a is 0, so we have x square, and then we take the second derivative of the function and then put the value of 0, and then so on up to the required value of n. Now in the summation form, we can write as 0 to infinity f of n of 0 over n factorial x raised to power n. Now on your screen, we have given you some important Maclaurin series expansions. The expansion of sin x, cos x, tan x, e raised to power x, and a raised to power x. Now you need to remember each of the expansion because it is very important and may be asked in your entry test examination. In the case of sine, we have odds in the power and it starts with x. In the case of cos, we get evens in the power and we have starting with 1. In the case of tan, again we got odds in the power. While in the case of e raised to power x, we have a special type of series, that is 1 plus x square over 2 factorial plus x cube over 3 factorial plus x4 over 4 factorial, while for a raised to power x, we have 1 plus x ln of a plus x square ln a square over 2 factorial plus up to so on. Now again, there is a big theory to find these series, so you do not need to get into the details of that. As you are preparing for the entry test, you just need to remember and memorize each of the series. So even if you are asked in an entry test, you know that what is the Maclaurin series of sin x, cos x, tan x, e raised to power x, or a raised to power x. Now you can be asked of any of the series, but these are some of the series that are very, very important and are often asked in your entry test. I hope you got the concept, and that's all from us in today's lecture.